compounds, last part. Hydrates is what is left from ionic compounds. I wanted to go over. You will have it at the end of naming ionic compounds, as I told you. So, what are hydrates? They are ionic compounds that are attached to some water molecules, and these water molecules are actually loosely attached. So, as soon as you heat them a little bit, this water is going to go away. How to name them, because it's an ionic compound attached to water molecules, so you need to name it as an ionic compound the way you learned it, and then instead of N, you need to use a Greek prefix for the number of water molecules. So this is basically for this. And instead of H2O, you will bring the word hydrate. Hydrate means water, right? Okay, so I have two examples for you. One from formula to naming, the second one from naming to the formula. CuSO4, if you remember, we had to mention the charge on excuse me, copper, because copper is a transition element. When you find the charge, is going to be 1 copper and 1 SO4 with a -2 charge, and the overall charge on CuSO4 is 0, right? So the charge on copper is 2 after you solve this simple quadratic equation. Now, how to name it is that you know it's copper 2 now. Copper 2 sulfate as the ionic compound. And what is the Greek prefix for 5? Penta, right? And instead of H2O, you bring this, you write hydrate. And one more thing I need to mention is that when you are writing the formula for the hydrates, you will see this dot here. Means that these water molecules are attached to the ionic compound part. So when you are writing the formula from the name, don't forget to put that dot here. So let's do this. Magnesium phosphate dihydrate. So let's take care of the ionic part first. Magnesium was in group 2, the charge was positive, right? Phosphate was PO4 if you go back to your polyatomic ion notes, and the charge was -3. What should you do at this point? You need to cross over the charges, right? Only the numbers, of course. So it's going to be Mg. What's the subscript for Mg is 3, because that was the charge of phosphate. And for PO4, the subscript is going to be 2, which was the charge on magnesium. So this is magnesium phosphate, and how many water molecules do we have? Di is 2. Dot 2 H2O. Please don't forget to put the dot, because that's a part of the rule for naming hydrates. That is naming hydrates. Very easy after you have learned ionic compounds, right? So the last part of our naming is how to name acids. Acids, as you know, they are composed of hydrogen ions plus nonmetals. Okay? So based on how many atoms do we have in acids, we separate them to 2 types of acids. Binary acids, which are composed of hydrogen ion plus a monoatomic anion, which is formed from nonmetal, right? So, how to name them? You definitely use the word hydro plus the root of nonmetal plus ic acid. So first of all, in order to write the formula of the acids, don't forget that hydrogen has a +1 charge, and anion here, chlorine, has a -1 charge, okay? When you switch them after crossover rule, you have 1 and 1. That's why you don't see anything as a subscript that I wrote in their formula. So how to name it? You bring the word hydro, you write it. Chloric. So that's our famous hydrochloric acid, which you can find in your stomach. This one, if H2S is an acid, first of all, the charge was +1 on hydrogen ion, on sulfur was -2, so when you switch them, cross over them, it changed to H2S. So, how to name them again? Hydrosulfuric acid. That's it. That's for binary acids, which is pretty simple. And the last category, the naming of the oxy acids. Oxy acids means that they all have oxygen in their structure. So we have hydrogen plus polyatomic anion. Do you remember these polyatomic anions? I wrote them for you again, and I want you to write them again, make flashcards if you have, and just basically go from polyatomic anions. If you remember, the anion with less oxygen always ends in ITE. The anion with one more oxygen ends in ATE. And the difference is always 1. 2 and 3, 3 and 4, 3 and 4. Okay? So, now let's make acids out of them and name the acid. I am trying to change the color of the pen. So we need 1 hydrogen because the charge is -1. So after we switch, the formula for acid is HNO2. For the other one, again, we have 1 hydrogen, HNO3. You see, +1 and -1, when they switched over, they don't create any substitutes. So the anion that ended in ITE now will end in OUS. So this is called nitrous acid. Nitrous acid is formed from nitrite. The nitrate ion will form HNO3, and the name for the acid is going to be nitric acid. Can you apply the same formula on the rest of them? So, after you add hydrogen ion to SO3, hydrogen has +1 charge, SO3 has -2, so you will have H2SO4, you need 2 hydrogen ions. It's going to be called sulfurous acid, and this is going to be called H2SO4, which is what acid? Sulfuric acid. And the same thing for phosphide and phosphate. Phosphide and phosphate have 3 negative charge, so they need 3 hydrogen ions. So after you write their formula, you will have H3PO3 and H3PO4. I'm sorry, this is 3. H3PO3 and H3PO4. So this is going to be called phosphorus acid. That's cool, they're using these colors. And this is going to be called phosphoric acid. Okay? So you simply relate the number of oxygens in the anion to the number of oxygens in the acid. Everything else is the same except the number of oxygens. And finally, you remember you had some more acids besides some more anions beside those. So for hypochlorite, you keep the hypo. The formula for acid is HClO. So you will keep the hypo. ITE changes to what? in the acids. OUS, hypochlorous acid, right? The second one, ITE, just change it to OUS, without the hypo, of course. It's called chlorous acid, right? For chlorate, you again need one hydrogen. You call it chloric. And again, you need one hydrogen to create HClO4, to call it perchloric acid. Some more, and this is going to be the last three compound. You need two hydrogens because this is going to be H2CO3 because of the charge on carbonate. So this is going to be called carbonic acid. This is what is called acid rain. Have you ever heard of it? This one needs one hydrogen because it's going to be HC2H3O2. I told you, this is an organic acid, so don't worry about learning the names, and don't worry about this fact that we have total 4 hydrogens. Why do you separate one of them? Just tell you before you go to the higher levels of chemistry that this hydrogen is considered our acidic hydrogen. So this is just called acetic acid, the acid in vinegar that we can drink. And if you remember, this cyanide ion jumped into the category of polyatomic anions, but it's actually ending in IDE, just like binary. The anion, just like the monoatomic anion. So you will have the name of a binary acid at the end instead of polyatomic anions and oxy acids. So you will have hydrocyanic acid. So because your anion ended in IDE, the formula for the acid will follow the formula of the name of binary acids. So this is the end of naming compounds. You learn how to name ionic compounds, molecular compounds, hydrates, and acids. You have the PowerPoint slides and some examples in them. You have your textbook and examples in them, end of the chapter problems. And also I have a worksheet for you, plus the nomenclature lab. I encourage you to start answering the questions even in the nomenclature lab. Don't wait for the correct exact date to come for it, but you can start working on them. So I hope these 3 videos were helpful to help you understand this naming, which is a big concept, and I admit it's not very easy, but it needs a lot of practice. Please don't give up, and keep practicing, keep using the tutoring center, and come to my office hours. Okay? Until next time, goodbye.